In this video, we're going to be continuing to talk about the unit circle, and we're going to talk about intervals of 60 degrees first. So if we have a 60-degree angle and another 60-degree angle, then we end up breaking up 1 pi into 3 pieces here. So if I was to measure all the way over to here, I would have 1 pi, but if we measure in 60-degree intervals, we break it up into 3 pieces. So what we end up getting is 60 degrees, or 1/3 pi, and here, so that would be that angle. If I continue to draw an angle that goes all the way over here, then now I have 2/3 pi, or 120 degrees. And then if I was to continue it, I would have 3/3, which is why we get a full pi over there. So we're talking about intersections on the outside of the circle and the coordinates that we get from there. So again, we're going to be using sine and cosine, and we're going to figure out the coordinates that are intersected on the outside of the circle there. So if we think about our special right triangles, and in the last video we focused on the 45, 45, 90, yeah, that's all kinds of gross. This time we're going to focus on the 30, 60, 90 special right triangle, and that's going to help us get our values here. So if we had a right triangle with 30 and 60 degree angles, then we have these ratios from the sides. Across from the 30 is the short side, and we're going to simplify it to just say it's 1. And then across from the 60-degree angle is the longer leg, or the longer side, and that's always the short leg times the square root of 3. So 1 times the square root of 3 would just give us radical 3, or the square root of 3. And then the hypotenuse in this special right triangle is always double the short side. So if the short side is 1, then double that would be 2. So we're going to use these ratios right here to help us find the values. So let's get going. So the sine is going to give us the y value. And so if we have a 60-degree angle here, the sine of 60 degrees is going to be equal to opposite over hypotenuse, or in other words, we're going to have y over r. And so if we look at this triangle, across from the 60 would be the square root of 3. So that would be the y in that case. And the hypotenuse, or r, would be 2. And so the sine of 60 degrees gives us a y coordinate of the square root of 3 over 2. So in our coordinate pair, we have the square root of 3 over 2 as the y coordinate. And the cosine is going to give us our x. So the cosine of 60 degrees is going to be equal to x over r, or adjacent over hypotenuse. So if we go back to this triangle, the adjacent side of a 60-degree angle is 1, and the hypotenuse is 2. So 1 over 2 is the x coordinate given a 60-degree angle. So these are the coordinates intersected by this radius if we have a 60-degree angle. And if we go over to this side, we have 120 degrees, or we also have a 60-degree angle going from that direction. It's also known as the reference angle. We'll talk about that in a different video. So we end up getting the same values, because 60 degrees is the same value as 120 degrees. So we end up with these same values, but just like in our last video, the only thing that changes is the sign, the positive or negative sign. And if we're in quadrant 2, the x value is negative, so we have a negative 1/2. And the y value is still positive, so it's still the square root of 3 over 2. And this pattern continues all the way around the circle as long as we're going in these 60-degree increments. So if we go down to this third quadrant, let's draw them both while we're at it. Continuing around. So now we're sitting in the third quadrant. We went a full pi or 3/3 pi radians. And now we're over here, so that's 4/3. 1, 2, 3, 4 pieces of pi. So we got 4/3 radians. Or in degrees, we have 180 plus another 60. Or in other words, we have 240 degrees. So given an angle of these measurements, we're going to talk about the coordinates that we get when we measure that angle. Alright, so again, our pattern just continues. The only thing that changes is the sign. So given those angle measurements, we intersect our unit circle at the coordinates. It's still going to be 1/2 as the x, still going to be the square root of 3 over 2 for the y, and the only thing we have to change is the sign. Since we're sitting in the quadrant 3 or third quadrant, both x and y values are negative. So there are the coordinates given that angle measurement. Let's get rid of that because we're not talking about 60 anymore. Alright, so we just keep going. So then we count another third pi piece here. And we end up in quadrant 4. So that would be 300 degrees. Or in terms of radians, we have 1, 2, 3, 4, 5/3 pi. And so if we have an angle that measures that, we're going to intersect our unit circle right here, and the coordinates are going to be similar. The only thing that's going to change is the sign. And since we're in the fourth quadrant, our x value is going to be positive, but our y value is negative. So those will be the coordinates intersected at that point. And if we went another 60 degrees, we would end up with our full circle, 360 degrees, or 2 pi. So there is our 60-degree intervals, or 1/3 pi intervals, all the way around our unit circle. And we're going to do it one more time. This time we're going to do it in intervals of 30 degrees, and just kind of change some things around. You're going to notice a pretty simple pattern to get used to. Not a whole lot different than what we just did. In fact, we just switched the quadrants, or I'm sorry, the coordinates. And so, real quick, let's just redraw our triangle. If that was our 30, that would be 1. If that was our 60, this would be the square root of 3. That would be 2. So now we're measuring in 30-degree increments all the way around the circle. I'm just approximately drawing these. Not very well, obviously, but so what we end up getting is thirds all the way around until we get to that full pi. And so in order to create a full pi in 30-degree intervals, we end up counting by 6, because 1, 2, 3, 4, 5, 6 pieces give us a full pi. So every 30 degrees ends up being 1/6 pi, or pi over 6 radians. So if we intersect our circle at these points, we have a slightly different coordinates. So let's look at our special right triangle. And remember that the sign is going to be the y value, or the opposite over hypotenuse. So the opposite from our 30 is 1, and our hypotenuse is 2. So we end up getting our sine value is 1/2. So now the y-coordinate is 1/2. And if we talk about the cosine, that would be adjacent over hypotenuse, or x over r. And so the adjacent side of the 30 is now the square root of 3, and the hypotenuse is still 2. So now our x value is the square root of 3 over 2. So really what ended up happening from what we just did is these got swapped. Now the x value is the square root of 3 over 2, the y value is 1/2. And this pattern continues all the way around our circle. So if we add another, that was 30 degrees, if we add another 30 degrees, we end up at our 60-degree increments that we just talked about, and that would just be our coordinates flipped here. And we get to our quadrantal angle. We already discussed that a couple videos ago. If we keep going, we get to another 60-degree increment, or that 120 degrees, and that was that. This coordinate, the 60-degree values, except that our x value is negative. So then we keep going. Now we finally get to our other 30-degree increment, because there, if we go backwards there, that's a 30-degree increment right there. And so it ends up being the exact same as if we were to measure all the way across here and get to there. So if we had gone 30, 60, 90, 120, 150 degrees, that would be the same values, the same coordinate values, except for the sign changes, as a 30-degree measurement. So we're in quadrant 2, so we know that our x value is negative and our y value is positive. Okay. And then in terms of radians, we would count our pi pieces here in 6. 1, 2, 3, 4, so we get 5, 6 pi radians. That would be the coordinates for those angle measurements. And then we just keep going around the circle. Same patterns. Now we're in quadrant 3. Keep measuring around here. We discussed this with our 60-degree increments. So here would be another 30 degrees. So we would find, and actually there's a nice little pattern here. If you just look across, like if you continue that line all the way across, you find that they're the same values. That's another pattern that you can use to help you remember values. Look across from the unit circle. So over here we have another 30-degree increment. So we'd have the same values, square root of 3 over 2, and 1/2. And since we're in quadrant 3, they're just both negative values. And that would be, we got 6 radians, 6 pi radians. So the angle measurement would be 7/6. We have another pi piece there. So 7/6 pi radians, or in other words, 210 degrees. Those angle measurements will give you these values, those coordinates. Keep going. There's another 60-degree increment. We discussed that earlier. Another quadrantal angle if we keep going. And so, getting close to the end here. Couple more 30-degree increments. Another 60-degree increment right there. And so we finally end up at our last 30-degree increment right here, because if we were to look backwards there, that would be our 30 degrees. That would be our reference angle. And so we end up with the same values. We still have the square root of 3 over 2. And we still have 1/2 as our y value. And in quadrant 4 now, the x value is positive and our y value is negative. So there's our 30-degree increments. So we talked about our 60-degree increments, 30-degree increments all the way around the circle. We talked about in our last video the 45-degree increments, and before that we talked about our quadrantal or 90-degree or 1/2 pi increments all the way around. So now we've fully broken apart our unit circle and talking about all the coordinates that are intersected. So we'll just put it back together and talk about how we can evaluate trig functions in our next video. See you there.